This is the brief on visualizing surface integrals. So, if you've ever, struggled to actually picture a cross product in your head, there's this interactive tool that is a total game changer. It basically swaps out pages of dense algebra for dynamic geometry, so you can see exactly how these vectors behave in 3D space. First, let's talk about decoding the map here. The tool uses this really simple color scheme to do all the heavy lifting, right? You've got a green vector, that's your position. Then there's a yellow vector, and that represents the surface normal. You can just think of it as an arrow pointing straight out from the surface, at a 90-degree angle. But the crucial one is the orange vector. This one shows you the result, the tangential vector created by the cross product, kind of shooting off sideways. Second, and this is where it gets really cool, static images just don't cut it. This tool actually lets you grab these little red points on shapes, like a sphere or a cylinder, and just drag them around. And as you do that, you get to watch those arrows update in real time. You're actually seeing how changing the position shifts the direction and the magnitude of the result, instead of just, trying to imagine it. And finally, this is where you get that big aha moment about symmetry. So when you add multiple points, you start to see that for a closed shape, those orange vectors on opposite sides, well, they point in the exact opposite direction. They're essentially fighting each other. And this visually proves why the whole integral results in a zero sum. It's because the vectors just perfectly cancel each other out across the whole thing. So really you don't need complex volume calculations to understand zero-sum integrals when you can just see the symmetry doing the work for you. Seeing the geometry, it really is the cheat code for mastering the calculus.